So we're going to walk through the first part of Unit 7 today. We're really not getting into the adding and subtracting polynomials part. We'll talk about that more tomorrow. We're just really looking at classifying polynomials and some vocab dealing with polynomials. So vocab your book gives you. A monomial is a number, a variable, or the product of a number and one or more variables with whole number exponents. And that's a lot of words. The key there is the idea of whole number exponents. Polynomial is when we put a bunch of monomials together, and you recognize those prefixes: mono meaning many, and poly meaning, mono meaning one, poly meaning many. So back to that definition of monomial. Monomial is a number, a variable, or the product of a number and one or more variables with whole number exponents. These are all monomials. So if we look at y, 10 is a number. When we say 10, that's the same as saying 10x to the 0 power. 0, anything to the 0 power is 1. 3x, same as saying 3x to the first, so it satisfies that condition of having whole number exponents. Remembering again, 0 is a whole number. 1/2 ab squared, we have a fraction, but that's not the exponent. The fraction's okay. A, remember, has its own exponent, and b has an exponent of 2. Negative 1.8 m to the 5th, again, whole number exponent is the key. When we talk about these monomials, each monomial has a degree, and the degree of a monomial is the sum of the exponents of all the variables in the monomial. And like I said a minute ago, 10 is the same as 10x to the 0 power. We say the degree of that monomial of any number is of degree 0. I learned something from this new book, told me that 0 doesn't have a degree. I did not know that before now. 3x, because the exponent is 1, has a degree of 1. Negative 1.85 m to the 5th has a degree of 5 because of that 5. If we have more than one variable, we add their exponents together. So a to the first, b to the second. This term, this monomial, would have a degree 3. We're not going to do that too much in Algebra 1. I just want you to know that it's out there. So these things are monomials, same as that last table we just looked at. These things on the right are not monomials. Let's figure out why. 5 plus x is not a monomial because there's two terms in there. We separate them, we'll call them terms. And we'll talk about something like that in a minute. The second one, that would be 2n to the negative 1. That is, negative 1 is not a whole number. We can't have a variable in the denominator. That's not a monomial. If our exponent is a variable, not a monomial. If the exponent is a negative number, not a monomial. Same thing holds true if we had like a square root of x, or an absolute value of x, or x to the 4/3 power. Anything strange looking is not considered a monomial. It has to be whole number exponents. So if we look at, the question is, what is the degree of each of these monomials? Again, it's the sum of the exponents of the variables. This one would have degree 2. When we have more than one variable, we add them together. So b would be of degree 4. C would be degree 6. That was 3 and 3. And negative 3 is negative 3x to the 0 power. That's degree 0. We have polynomials, which are just a bunch of monomials added together with addition or subtraction. So it's a single monomial is still considered a polynomial, but we look at the sum of monomials as being a polynomial. So polynomial is kind of what we call it, an umbrella term. All polynomials fit under this umbrella term, including monomials. There are some other special terms for specific kinds of polynomials. If a polynomial has 2 terms, we call it a binomial. If a polynomial has 3 terms, we call it a trinomial, and you can see why from the prefixes there. We really only call polynomials monomial, binomial, trinomial. If there's more than 3 terms, we just call it a polynomial with however many terms. A polynomial with 5 terms, a polynomial with 10 terms. So we have special names for 1 term, 2 terms, 3 terms, but not really anything higher than that. And again, the terms in a polynomial are separated by pluses or minuses. 1 term, 2 terms, 3 terms. Term, term. We talked about degree of a monomial a minute ago. The degree of a polynomial is the greatest degree of all its terms. So this polynomial has 1, 2, 3, 4 terms in it. We don't add the degrees of each of the terms together. We just look at all of the degrees individually. Degree of the first term is 3, second term is 2, degree of the third term is 1, and the degree of that last term is 0. I say the degree of the polynomial is 3. So I take whatever degree is highest, and that's the degree of the polynomial. We talk about a couple vocab words here. This last term that's by itself, we call that the constant term. So it has no variable with it. It's not changing as the variable changes. We talk about polynomials being written in standard form. Standard form looks like this. We call it decreasing order of exponents. So we have an x to the third, an x to the second, an x to the first, and an x to the 0. That is considered standard form. If they're mixed up, we rewrite them and put them in standard form. When we do that, write them in standard form, the number in front of the highest degree term is called the leading coefficient. So we talk about classifying these polynomials. This was one of our learning targets, or one of our standards for this lesson. Classify them by the number of terms and by their degree. Some of those degrees have special names. If the degree is 0, we call it a constant polynomial. Like a number 6 would be a constant polynomial. Constant monomial, I should say, because there's only one term. If the degree is 1, we call it a linear polynomial. In this case, linear binomial, because it has 2 terms. And we know why it's linear. If we graphed y equals x plus 3, you know we would get a line. Anytime the degree is 1, when we graphed it, we'd get a line. We call that a linear polynomial. 2 is the weird one. We call it a quadratic. Quad, which sounds like 4, that really means x squared. I think the Spanish word for square is cuatro or something like that. In this case, 3x squared, the degree is 2, that's quadratic. There's only one term, so we would call this a monomial. You might have a 3x squared plus 5x plus 2. That would be a quadratic trinomial. So classified in 2 different ways, by the degree and by the number of terms. If it's an x to the third, we call that a cubic polynomial. In this case, a cubic trinomial, because there's 1, 2, 3 terms. The book gives us words for, and some books use these more than others, for 4th degree and 5th degree. The words are quartic and quintic. I never say those words other than on this day where I'm giving vocab. So we can just say a 4th degree, in this case 4th degree binomial, or a 5th degree polynomial with 4 terms. I can't get much more specific than that. If you want to remember those words, quartic and quintic, they're kind of cool words, but we can just say 4th degree, 5th degree. That constant was of degree 0, just a number. So it sounds like we put a lot together. It's really just vocab. So I'm going to give you some problems here, and we'll see if we can work out the names of these polynomials. 7n minus 3, so we're going to classify by degree and number of terms. There are 2 terms, so this should be a binomial. And as I scan through this list, this is the only one that has binomial in it. Is it linear? Yes, because that's 7n to the first power. Flashback. The number 4. Number 4 is a monomial, and I'm seeing quadratic monomial, linear monomial, or constant monomial. And so that answer should be a constant monomial. 7b to the second, again a monomial. The only 2 here with monomials are these 2. It's not linear because it's not to the first power. This is one of those x squared, or b squared in this case. That is a quadratic monomial. We'll use quadratic a lot. We'll do a lot with quadratic equations, so get used to hearing that word. It means to the second power. This one, again, as I scan through, I'm seeing 1, 2, 3 terms. This should be a trinomial. The only one with trinomial is this one. Is it a 5th degree? Yes, it is a 5th degree trinomial. As I look through these, let's see, we have a to the third power is cubic, and there's one term, so cubic monomial. Next one is a number by itself, constant monomial. And look, oh, there's another one, same thing. And the last one, I have 3 terms, highest degree is 3, so it should be a trinomial, cubic trinomial. All right, why don't you pause here, see if you can come up with the right answers without the multiple choice option. When you're ready, go to the next slide, I have the answers for you. All right, just check your work here, okay? You can hit pause and then go on. All right, next set of problems would say put the polynomial in standard form, name it by its degree and number of terms, and then name the leading coefficient. So that just means rewrite it in standard form. And again, standard form means going from highest degree to lowest degree. If I look at number 1, the highest degree of those terms would be 6b to the 6th because of that exponent. So I'm going to write this 6b to the 6th. The next highest exponent is this one. I want to make sure I bring that negative with the 7, so minus 7b to the 5th, then plus 3b to the 4th, plus 8b. So this is written in standard form. Again, decreasing order of exponents. I can name it by degree and number of terms. This is just a 6th degree polynomial with 4 terms. Its leading coefficient is the number in front of that first term. So its leading coefficient would be 6. Okay, take a minute and try these other 3. Okay, so I wrote these up kind of messy. Number 2 is already in standard form. Its leading coefficient is 5. Its degree is 0. It's a constant monomial. And you can read through the other ones, LC meaning leading coefficient. And that comes from this number, not this number. All right, and then same thing for these, and then you're about caught up. I will post a PDF with just some practice problems. And that's it. I think you're all set. Hope you feel all right.